This particular demo is meant to be an introduction to the auto generation tool and basically show what it can do for users and how to start the auto generation by entering the input data for the auto generation of a control system, or as we call it, design input data, which usually is taken from the customer or end user of the control system, and engineers have to enter it in spreadsheets or in some other way as input to the auto generation tool. So this is the front-end graphical user interface of the auto generation tool. As we can see, it's divided into several views or control panes. One of them is the auto generation dashboard, and in the lower part there is project specific data which is being shown to the user once and allows it to navigate to the project data once an open project has been opened in the dashboard by the dashboard. The dashboard itself has two kind of controls. One is for controlling and manipulating and modifying auto generation templates, because the whole auto generation process is based on templates. The templates are in general text files or text entities, which could be templates for auto-generating PLC tags. In general, that's a text tag descriptor, which has the tag name represented by a placeholder for the tag, the tag type, and like a command or tag description. And the auto generation process would take this tag descriptor and replace the tag placeholder with a real tag for the control system, taken from the design input data entered by the engineer for the particular control systems project. Or for PLC code, again, we've got templates for all sorts of control items or control entities in the control system, like drives, motors, valves, PID controllers, and all that. All is based on standard code for which we've got templates. And again, the auto generation process would take the template and replace generic tag placeholders with real tags for the control system entered in the design input data for a particular project by the engineer that is generating the control system and creating the control system or developing it. So these are the templates for, as I said, everything is represented by template in the auto generation process, whether it be PLC code, PLC tags, or SCADA graphic items like indicators or motor genies or whatever it might be in the SCADA system, or in the FDS as well. We've got templates for generating parts of the FDS or the functional description. The other part is the Pro SCADA on the control systems project control and manipulation part. So as we can see here, we've got 4 ways to create a new project or open an existing project. Either we create an empty new project, which is basically has no data in it, and the user has to define the data fields themselves, as well as enter design input data into the project. And this is the most difficult way to do that. Another way to create an auto generation project with all its data, I forgot to mention, actually all the data for auto generation are stored in Excel spreadsheets, And as a rule, or in general, for each of the auto-generation steps, like for PLC auto-generation, code auto-generation, we have a separate spreadsheet, and for SCADA auto-generation, we have a separate spreadsheet. As well, for functional description, we have another spreadsheet. So as a minimum, we would have two spreadsheets for PLC code auto-generation and SCADA code auto-generation. But each separate auto-generation artifact, like FDSs or alarm tables or FAT documents, would have a separate spreadsheet for auto-generation. And if the PNID drawings for a particular control systems project are good enough and have enough information, they can be used to read data from them and enter it in automatically in the spreadsheets as design input data. That's one possibility to create a new project as well. And a third possibility is by using an existing one and retaining all the data structures for control items like valves, I/O points, motors or control sequences, and just deleting the specific project records for the old project from there, but all the data structures and data properties of control items like valves and motors would be retained, and the user has just to re-enter the new data for the new project in there. And finally, we can open an existing project, modify its data, and then re-auto-generate new items out of it. Or the user can open an existing project, enter only a few records in there, auto-generate code only for them. For instance, for a new motor that he decides that needs to be added to the existing control system, he can enter a record only for this motor and auto-generate data only for that motor, and then later on import all this auto-generated data into the PLC code and the SCADA system and add a motor in that way. That's also possible. So for demonstration purposes, I already created a small project which we will open, and I'll go through all the data properties of the project and how to enter design input data manually. We won't be showing here how to do that with a PNID because this functionality is not implemented yet. It's a matter of the future, as we can see here. So here's the small project that I've already created, and it's got only a few control items like 2 I/O points, 1 digital and 1 analog, and 1 motor. But for the demonstration purposes, of course, this is not a real project, but for demonstration purposes that will do. So at the moment, the graphical user interface is getting all the data out of the project. The GUI is flexible itself. It doesn't know anything about the data in the spreadsheets for a specific project. It reads all the data and identifies all the data types for a particular control item and just shows them here in the GUI, or you can modify data in the GUI as well. But the GUI itself doesn't know anything about the control items in a particular project or what type of control item it has. It has to read it all dynamically and present them in here. So as we can see, for a particular project, we always have two views. And the right-hand view is this one, and the left-hand view. The right-hand view presents the project and all the data structures for particular control items being used in the project. For instance, for I/O points in an I/O list, we've got records for I/O points, and they have the following data structure. So For this one, we've got the tag descriptions. So from all these tag data properties, we form the tag. Usually customers have requirements for tag construction, and for instance, for the batch control S88 standard, tags are defined by plant location, plant facility identifier, then plant facility sub devices, sub items, control items, and so on. And this is represented here in this first 5 fields. This describe the tag rules in which to form tags. From here you can navigate to the fields describing these tags in the spreadsheet, and as you can see, here are the tag creation fields. The user has to enter the data for each of the records for IO points for these ones. And in the spreadsheet, I will go a bit more in detail here. All the brown fields and white fields have to be filled out by the user. Brown fields in general are list restricted, so the user can choose from a list. For instance, for the plant location, the user can choose from these plant locations which are predefined for this project. Same for the plant facility. You've got several choices like totalizer or transmitter or whatnot, level indicators, temperature indicators, LSH, LSL, which is low alarm, digital inputs, and whatnot. So the gray fields, the user doesn't have to enter anything here. These are all calculated fields represented by Excel formulas, meaning that the data that is shown in these fields is calculated by using other columns or column data and applying calculation rules. So this particular column here shows the tag name used in the PLC in order to control items. Then we've got here the IO type in this particular case, descriptions. For analogs, we've got engineering units, minimum and maximum, alarm levels. For IO, again, we've got if it's a Unity PLC, we've got the physical address that we have to assign, then in which PLC the code will be placed, and MCC number for drawings, MCC drawings, and if it's an alarm, it has to define an alarm tag in the PLC that we are monitoring in SCADA, and other such properties or data items. Each data property for specific control item is, as we can guess, is defined by columns in the spreadsheet, and also for each control item like drives, valves, IOs, controllers, PID controllers or totalizers or whatnot, or sequences, we've got a separate spreadsheet in the auto generation spreadsheet. This particular auto generation spreadsheet is used in the PLC auto generation. There is one more, as I mentioned, and that is the SCADA auto generation spreadsheet, and that again has got for each control item like IO lists, drives lists, controllers, and whatnot. It's got a separate spreadsheet, again having the control items as records in here. So in the GUI, the graphical interface, we've got another view which shows the control data view, and that basically shows all the records for control items in the spreadsheet. So this pane here shows all the columns for control items or data properties of the control items, where this one shows individual control items, and we can navigate again from here to the record. For instance, that's the record for a digital input, that's the record for analog input, and so on. So that's the record for the motor, for instance, and for real life projects you would have many more records in this pane. But for this small project we've got only 3 items in here. So once we have entered the data for control items and the records are finished, and we are finished with the project, we can go on and start the auto generation process. But prior to that, there is one more check that we need to do, and that the auto generation tool does it automatically for you. When you click on this action trigger, it does data consistency check, meaning that it would check for a motor that all the I/O points required in order to control the motor in the control system are entered, and all the data in it is entered, and it's consistent and free of errors. So once we start the auto generation process, we make sure that it will go through successfully and there will be no errors in the auto generated code. So if there are errors, this check data consistency action would detect them and generate a report here, check report. The user has to look at the report and correct the errors that have been detected. Once the errors have been corrected, the user has to reinitiate the check data, and once that has passed, we are ready for auto generation of the PLC code or the SCADA code or the functional descriptions. And that's pretty much all in terms of entering design input data into the spreadsheets and the introduction to this auto generation tool. Further, we will show in other demos how to auto generate PLC code and how to import it into the PLC program, as well as how to auto generate SCADA system data like tags and SCADA graphics.